Hi everyone, in this video I'm going to walk you through a few examples of how to use the online graphing calculator found at desmos.com/calculator. I'm going to give 4 examples here which will be subdivided into 4 different parts of this video. Example 1. Graph the square root function and flip it over the x-axis, shift it right 3 and then down 2. Then we're going to hide the graph. So here's what the calculator looks like when you come in. You can type any basic function that you may think of with the keyboard, such as the linear function 3x plus 4. And there's the graph of that line. It's a very simple one that can be used with the calculator. Now the square root is one where we cannot use the keyboard. So if we go down here to the left corner, you see show keypad. You click that and now you get an option here. This is also helpful for some mobile devices for typing expressions. But there are also things keyboards can't do, such as less than or equal to, or absolute value, and there are other functions such as trigonometric functions and even logarithms, which we will use later in class. For now we want to use the square root function, so I will click square root. And the calculator understands when you type the letter x, that is meant to be the independent variable or the variable plotted on the horizontal axis. So there's the square root of x graph. Let's go look back at our instructions, and I'm going to hide the keypad here. We're going to flip it over the x-axis, shift it right 3 and then down 2. Alright, so hopefully you recall that a flip over the x-axis can be obtained by putting a negative in front of the square root. And notice the graph as I do this. I put the negative and it flips it over. I take it away, I put it back. I take it away and I put it back. And you can see how it flips it around the x-axis. So now we've flipped it. The next step was to shift it right 3. Maybe you recall from section 2.7 that a horizontal shift is the one that is not as intuitive. Right on the x-axis is positive, and in this case we want to shift it right 3, but we don't put a plus 3, we put a minus 3. And we also do it inside parentheses, or in this case inside the square root. Now vertical shift down of 2 is intuitive. It's minus because negative is down, and we move outside of the square root and put the 2. And now the graph has been moved down 2. So that graph is one that has been flipped, shifted right and shifted down according to the example. And the last step we wanted to do is we're going to hide this graph. So we don't need to delete it. You can delete it if you make a mistake. Click the X and it will delete it. But you can also click here on the color and it takes the graph away. Click again and it comes back. So you can take graphs away, you can add them back by hiding that there. So instead of deleting them, you may wish to hide them. Example 2. Graph a quadratic function in vertex form using sliders for the vertex h, k. So in example 2, we're going to do the vertex form. Now you can type this in, but also I wanted to show you that if you click on the 3 bars here on the left, you can find some built-in functions such as parabolas in vertex form. And it already has built in the vertex form with the coefficient a and the h and the k that I was referring to. And in fact it highlights and labels the vertex itself h, k. So we're going to modify h and k using a slider. We have our sliders, I'll show you how they work, and now we're going to set the slider so that it increases by integer amounts only. So if we click on the slider for h, you click in the box and it says how do you want to vary h. So let's vary h from say -10 to +10, and we're going to step it by 1, which means it will go up by whole numbers. Okay, so there's our slider that's been modified. K will do the same as well, but for now, let me show you how h works when I do that slide. You can click the play button here, and you can see how it's moving it up and down the line. You can change that by clicking the animation properties and make it move faster. So as we see there, we see that as h goes up or down, and so it's going back and forth and up and down, we can see that it goes left and right. So changing h in this vertex form moves the graph left and right. I'm going to pause that and I'm going to move it back to 0. Alright, so I'm going to leave k just as instead of being stuck on integers, I'll show you what it does. You can also move it decimal amounts, which is what it's doing now. Alright, so we see what k does, so you can drag it that way as well. And so with k, we see moving it down moves the parabola down, moving it up moves the parabola up. And so that is the relationship between h and k and a parabola. So that's the relationship between h and k. Now the other question was, what is the vertex? And you notice the vertex is labeled here for you, HK. And so we slide that forward and the vertex moves and the coordinates move with it. So right there the vertex is 3, 1.9. Another thing you can do is find the y-intercept is one thing that it requested to find. If you click your mouse and just drag down, you can pan. And if you use the little roller button on your mouse, you can zoom out. But if we click on the function itself and turn it, it's got a little bit more bold red. Notice how it puts a little gray dot there because it knows that's an important point to a lot of math students, because that's where the function crosses the y-axis. And so 0, 10.9 is the y-intercept. And our final question was, what are the x-intercepts? I'm going to zoom out some. Where does this function cross the x-axis? It doesn't in its current form. But notice that if I drag it and drag k to be a negative number, it does start to cross the x-axis and in two places. So I'll click on my function again to turn it bold red, and now I have numbers for the x-intercepts. They work just like the y-intercept, where you can click on them, and once you click they stay, so you could write them down or make note of them. So that's a little bit about how sliders work. Some animation where you can control the animation, and here where you can just use a free slider. If you wanted to recreate that manually, you can do that as well. So we want to use a parentheses x minus h and close the parentheses, and then to square something you can use the keypad down here if you like to do a squared, but I like to just use the keyboard. I hit shift and then the number 6, which is the caret symbol, and notice how it raises it up to the exponent position, and I type a 2, and so then you type plus and you put k, and so the calculator knows that x is the variable and it wants to know what is a, h, and k, and it assumes that you want to add sliders for those. So you can add sliders for any one of them or multiple of them, or we're just going to add sliders for all. And just like that, we can create our own sliders, and we have the same editing functions we have for sliders as we had in the previous example. Example 3. Graph the following piecewise function. So we have these 3 pieces and their domain restrictions. We're going to set the viewing window to go from negative 10 to 10 on the x-axis and negative 100 to 10 on the y-axis. What's the value of the function at these various points? So let's get busy creating this. So I've turned off my previous function again. You can turn that back on or turn it off. You don't need to delete it. My first piece of my function is negative 0.1 x to the third. My domain restriction was x less than negative 4. If we go back and look, for all the x's less than negative 4. So to add a domain restriction for a piecewise function, you hit shift and you use the bracket, the little squiggly bracket, and we're going to go say x less than 4. So I can use the less than symbol from my keyboard to do that, and I apologize, that's negative 4. So you notice what it did is it chopped the function off. It says it's going to be negative 0.1 x to the third all the way up until x is negative 4, and then it chops off the rest of that function. Alright, now the next piece of my function, 3/5 x minus 2 from negative 4 to 0 with less than or equal to on both ends. So 3/5, if you want to type a fraction, you just need to type 3 and then hit the slash key, 5, and it knows it wants to make that a fraction. And now we don't want to put the x there, that's 3 over 5x, so we need to move our arrow out to the side, put the x there, minus 2. Alright, so that domain restriction went from, again, put the little squiggly brace, and it goes from negative 4. Now it was a less than or equal to, so I have to come down here and use the keypad, x less than or equal to 0. I'm going to hide my keypad so I can see my function. So there's my next piece of my function, 3/5 x minus 2 from negative 4 to 0. My final piece of my function, 2 over x minus 1, that's for all x is greater than 0. So again, I used 2, hit my slash key, and it automatically made a fraction out of it and did x minus 1. So I right arrow to get back up here and do bracket x greater than 0. So I'm going to zoom out a little bit so we can see all the function. So this is a very gnarly piecewise function. We have these 3 pieces, the red piece, blue piece, and the green piece. The next step of this problem is to set the viewing window. So to adjust the viewing window, what you do is you come over here in the upper right hand corner and you click Graph Settings. In our instructions it said to make the x-axis go from negative 10 to 10. So you can come in and type your own numbers, and on the y-axis we wanted to go from negative 10 to 100. And so in that way we can zoom out from our graph and maybe specify a range of numbers that make the most sense to us. If we go back to my graph here, or my question, it says what is the value of the function at x equals to negative 5? Alright, so one way to do that is to click and hold your mouse down as you slide along the function. So I'm going to keep sliding until I get to negative 5. Now notice in this case it doesn't pin to it like it does when it's an intercept, but when x is negative 5, y is 12.5. So that's the value of my function there. But as soon as you let go of your mouse, that point is gone. You click it and it's gone. You click and it's gone. The next one, what is the value of the function at x equals to negative 4? When we get to negative 4, notice right there it says when x is negative 4, it is undefined. All right, we need to look at why that is. And the reason that is because this function is only the function up until x is negative 4. When x is actually equal to negative 4, notice that it's this function. So that's why when you get to the end of the red piece at negative 4, it says negative 4, comma undefined, because the value of the function at negative 4 is down here on this piece, and it's negative 4.4. The final question, what is the value of the function at x equals to 0? So when x equals 0, notice that means that is a y-intercept. So that point is one that I can click, let go of my mouse, and that point will stay. So the value of the function at 0 is negative 2. And also notice there is no issue with undefined because these two pieces were what we call discontinuous, but this piece, the blue piece, is continuous with the green piece. Example 4. Save the graphs above and generate a URL to submit for grading. Okay, if you're in the middle of working here and you have to stop and you didn't finish all your homework tasks, you can save these by signing in. You can click Create Account or Sign In. If you click the Sign In option, you have an option to sign in with Google, and many people have a Google account. Or you can sign in with a Desmos and create an account. That's how you would save it so you can come back to it. You'll sign back in. Now, for the purposes of your submitting for grading, you don't need to create an account. To share with me all of this work that you did here, all you need to do is click right there and do Share Graph. And to share your graph, you can do Share This Link. And you see when you get Share This Link, you click Copy. And now it's ready to be pasted. So you would go back over into D2L to the assignment, and then you would paste it there. And that will be a unique link to your graphs that you've been creating.